Okay, here we go. All right, so this is section 7.7. This is the last section we are going to do of the chapter. There is one more section, section 7.8. Section 7.8 deals with crazy word problems, just way more intense, using the number E. Priya, you're funny. So we're going to skip section 7.8 this year, just because of pandemic reasons and trying to lessen your stress level. Let's not go too crazy. So we will do one word problem today, and it won't be so bad. Okay, so find your calculator and you look here for the button E. It's a lowercase e, and when you press it, you should be able to get this number on the screen. I'm going to spotlight my, I don't know if this, let me stop sharing and then spotlight. Okay, so you should be seeing my calculator now, large. Find the E button. For me, with this calculator that I have, and it's a little blurry, sorry about that, but the E button is under this PRB log button. So wherever your log is, that's probably where your E button is. So I'm going to press second, and then this PRB button right here, log. And then you'll see I have these options on my screen. I have a log option. I have a 10 to the power option. And then over to the right, I have an LN option. That's where I'm going to go. So I'm going to go to the right where it says LN. And then I've got two options here. Option 1 is LN, and option 2 is E to the exponent, right? E to the power of. So find that E button. When I press it, it gives me an exponent box. I'm going to press an exponent of 1. Other calculators, I have a note to myself. Many calculators need you to put parentheses 1. So just play around with it. But when you press enter, you should see 2.718, the whole big long number. Find that button on the calculator. And just to make sure you've got it, just put in E squared.
Mrs. Ingley, what's the button called again?
It's an E button. It's a lowercase e.
Okay.
It's a lowercase e. It's probably where your log is, somewhere in that area. Look for LN. You might need to go over, like, so for me, it's second log, and then I press the right button to get to a different list.
Yeah, I got it. Thank you.
Good. Yep, you're welcome. So if you do E squared, you should get 7.389 decimal. So just make sure you can get that. If you can't, at some point, you might want to Google your calculator name and say, like, where's the E button? Because we need that button for sure today. So E is an irrational number. It goes on forever and forever. Spotlight. We'll go back to sharing. It's like pi, right? So pi is a number, 3.14. E is a number, 2.718. It is irrational, it goes on forever. We usually just say, when someone says, like, what is E? You usually say 2.718. Discovered by Jacob. Isn't he a handsome dude? Discovered by Jacob in 1683 when he was studying compound interest, but it's named after Euler. So I don't know if they were best buddies or what. I don't think so, because their age differences are a pretty big age difference there, but you never know. I don't know what the story is, never really looked, but it's named after Euler. So it's called either natural base E or Euler's number. He's also a handsome dude. Now, it was discovered with compound interest. I'm just going to show you this. You do not need to copy this or anything like that. Just look. So here is our compound interest formula up at the top. And what happened when he discovered this was he made the principal one, so like $1. He made the rate 100%, which is 1. And then he made the t 1. And then he kept playing around with the n value, how often you're compounding. So if he compounded 1 time, then he earned 100% interest. He had $2 at the end of a year. If he compounded biannually, he had $2.25. And then as he compounded more and more often, right, all the way down to every minute, he noticed that these outcomes were approaching a limit, meaning it was approaching a number that it would never go over, right? It would like kind of hit this glass, this ceiling. And so we call that a limit. We're approaching it, we never really get to it. And the number that we were approaching is E. E is the number we are approaching. So we are going to use E in a word problem today for compound interest. And we are going to be compounding continuously. Imagine that. Compounding continuously. It's like whatever time you're imagining, like a snap of the finger, imagine even faster than that. So compounding continuously, we use the number E in that formula. So stay tuned. We'll come back to that word problem later. But that's how this number was discovered. It was the limit when you compound more and more often. All right, so E is a number, not a variable. And keeping that in mind, let's think about what this would look like. If I asked you to graph y equals e to the x power, e is just a number, 2.718. So imagine if I asked you to graph y equals 2.718 to the x power. What does this look like? Right, anyone know what it looks like? Want to share? So this would be an exponential growth problem. Exponential growth, right? E is the base. It's a number larger than 1. So it's exponential growth. And so when we go to graph this, you can graph an exponential growth problem. You would say, okay, there's no vertical shift. So therefore the asymptote is at y equals 0. It's y-intercept, make the x value 0. E to the 0 power, anything to the 0 power is 1. So e to the 0 power is 1. So my y-intercept would be at 0, 1. Because it's exponential growth, because the base is bigger than 1, I know that my zoop looks like this. And that's my graph. So on your next test, next Tuesday, I might ask you to graph something like this. And you should have no problem doing that because E is just a number, 2.718. So you say, okay, that has a vertical shift down 4. So let me move my asymptote down to y equals -4. Let me find my y-intercept by putting 0 in for x. You'll be allowed to use a calculator to get this decimal answer. Plot the y-intercept, it's exponential growth, and so you draw the curve. Yeah.
When you get a decimal, so do you just approximately put like where it's supposed to be?
Yep, exactly.
Okay.
Yeah.
Thank you.
You got it. All right, so this was the more official looking graph from the textbook. They don't put their asymptotes in. I don't know why not, but that's what that looks like. So the review sheet is already posted. It has something like this on it. It's not that same exact equation, but it has something like that on the review sheet. So just remember the base is 2.718. When you put it into your calculator, do not put 2.718. On your calculator, use the E button because it makes a big difference. All right, so now what we're going to do is graph the inverse of this. If you remember from the beginning of the chapter, what's the inverse of an exponential equation? What does the inverse look like?
Logarithmic equation.
Yeah, very good. It's going to be a log. It's going to be a log. So here we go. Let's discover what that's going to look like. So to find the inverse equation, we are literally going to switch the x and y. Literally. And then we're going to solve for y. How do we solve for y? How do we do that? Can someone in the chat or out loud tell me, how do we solve for y?
Would you change it into a log or?
Yep, you got it. We're going to change forms, right? We're going to change forms. This is right now exponential form because the variable we are solving for is in the exponent, right? Y is the variable we're solving for. That's in the exponent. So right now, this is an exponential equation. We're going to change it to a logarithmic equation. So start with the base, go around the equal sign, and Jitesh put it in the chat for us. Log base E of X equals Y. And then usually you guys do some fancy stuff because you're awesome. And you say inverse equation. Let's use inverse notation there. Now, here's the thing. When you have log base 10, nobody writes log base 10, right? What do they write? They just write log because they know it's a common log. And so they don't do that. If someone did that in the math world, real math people would be like, what are you doing? Why are you writing log base 10? Well, guess what? Nobody writes log base E. Nobody writes log base E. So we're not going to do it either. Instead of log base E, we are going to change that to ln. The log base E got replaced with ln. ln stands for natural log. The argument was x, log base E of x. X was the argument. So x is still the argument. So ln of x. So technically, when you look at this, you're thinking, oh, there's no base. No, there is a base. It's log base E. So ln is base E. We call it natural log. I'm assuming it's backwards, ln versus nl, probably because of some Greek language kind of thing. No problem. Anytime, anyone who has Wi-Fi issues today, just don't even work, like get back on if you can. I'm going to post the lesson later, right? So if you missed 5 minutes of the lesson, you can go back and find those 5 minutes that you missed. All right, so this is ln. Now, we know how to graph logs. How do we graph logs? Well, when I graph a log, I know that the asymptote is at x equals 0, unless there's a horizontal shift, which this one does not have a horizontal shift. And then based on the base, we decide how the joop looks. The base here is base E, 2.718. So because that base is greater than 1, my joop looks like this, and that's my log graph. It's still a log, right? This is still a log function. It's just a natural log very specifically. All right, so here under here is the graph of the two inverses side by side. So you've got the exponential and the logarithmic with those E bases. How do we feel? Feel okay? This was just a big explanation of what E is, where it comes from, what it means. So now let's do some stuff with it. Woohoo! So let's just practice changing forms one more time, and then we're going to solve equations. In order to solve equations, you need to be able to go back and forth between the two forms. So let's take number 1 and rewrite it into logarithmic form. Right now it's an exponential form. Start with the base. So we'll do log base E, go around the equal sign. Log base E of X equals 8. And then we are always going to change our log base E's into natural log. So ln, keep the X argument, equals 8. Always change log base E, right? I want you guys to be the best mathematicians there are. So let's do this properly. I don't mind if you have log base E in your work, but when it comes to final answers and things like that, let's be proper. So number 2. Number 2 is a logarithmic equation. We're going to change it into exponential form. So if you need to, here's an example of if you need to change this to log base E. For beginners, which is what all of you are right now, for beginners, it might be easier to have this visual to change forms. So start with the base and go around the equal sign. So the base is E to the X equals 25. If you can skip this step here, you can. Right? Maybe you do it for today, and then maybe by tomorrow you're saying I can skip, right? All right, so we are now going to use this skill of changing forms to solve equations. So calculators are going to be needed. For numbers 3 and 4, we're going to round our answer to 3 decimal places. Number 3 is an exponential equation. I know it's exponential because the variable is in the exponent. When you see an exponential equation, your first thought should be, can I make the bases the same? That should always be your first attempt. It's the easiest thing to do. Can I make the bases the same? In this problem, no, I cannot. If you can't make the bases the same, then your only option is to change forms. Change forms. So start with the E base, change this to a log base E, go around the equal sign, and then change log base E to ln. Keep the argument the same. The argument never changes. If you can skip that first step, fantastic. Skip it if you can. If not, it's okay. Now, if this was a no calculator question, this would be your final answer. You solved for X. X equals log base 9, right? If it was a no calculator question, or if the direction said, leave your answer as a log, right? Something like that. College professors do that a lot, right? In college courses, I left my answer in log form all the time. Right now, we're not. Look at the directions. The directions say round to 3 decimal places. So grab your calculator, find the LN button now. The LN button should be very near where your E button was. And put in LN of 9. Right, you should be getting 2.197, 224577. It keeps going on and on. Yeah, Uday, that's correct for 4. The approximately symbol, guys, on your keyboard is option X if you're using your MacBook. Option X. Just so you guys know, fun fact. Right, option X. Okay, number 4. Number 4 is a log equation. So we're going to isolate the log, which it already is. and then change forms. If needed, you might want to do this. Some of you might be able to skip this step. All right, skip it if you can. Start with the base and go around the equal sign. And then grab your calculator and put this e to the power of into it. Yeah. When it says round to 3 decimal places, technically you should put those 0 zeros there because that's what it asked for. So if you're doing rounding, you should put those 0 zeros there. I mean, I wouldn't take off points for that, but some teachers are crazier than me, believe it or not, and they might. So technically you should put those zeros there. Now, if the answer was exactly 3.5 and the direction said round to 3 decimal places, if the answer was 3.5, then you should do this. Big difference between these two answers. Huge difference. Looking at this answer over here, it's 3.5, period. Like that is the answer. Over here, I know that there was rounding that happened, that I know that the answer was many more decimals than this, and this was the approximate answer. Right? That this is as close as I'm just showing somebody, but it's not the answer. Big difference. Big difference. Okay. So let's try, do we have time? Do we have time? I'm not going to rush. There are 2 more examples I was going to show you for solving equations that are a little trickier. I'll put them up at the end. Let me get to the other important topics. Okay, so we're going to switch gears a little bit, and now we're going to use our properties with these natural logs. All the same properties apply. Product property, quotient property, power property, inverse property. Natural logs are still logs. So all the same rules apply. No calculators right now. No calculators. So what the directions are asking me to do is condense these 2 logs down to 1 log. Now you might be looking at number 1 and saying, ooh, addition, product property. Yes, but not yet. This 4 ruins the product property right now. You can't add 2 logs with product property if there's a coefficient in front. How can I get rid of that 4? I need to get him out of
To
here.
the power of 4.
Very good. Yep. I'm going to use my power property, right? That 4 is allowed to go zoop, up into the exponent. I was not allowed to divide by 4 because it's not an equation, so I can't divide on both sides. I can't factor out a 4 because it's not really a GCF. That will make the problem even messier. So I put that 4 up there. 3 to the 4th is 81. And then you can do power property. And in school, I would make you suffer through this multiplication by hand. You can just use your calculator, or I'll tell you that this is 486. If you want to put the 486 in parentheses, that's also fine, right? Either notation is fine, your choice. Usually there's not parentheses unless you have like an expression of some sort, like x plus 2 or something like that. I'm not touching the calculator because this was a no calculator question. The direction said write it as a single log. It didn't say round your answer to 3 decimal places. All right, let's do the same thing with number 2. Super no calculator on this. And it is, we can do this with no torture, right? There's a way to do this pretty easily with no calculator. So go ahead, take those coefficients, 6 and 2, and chuck them up top. I'm not that crazy. Don't sit here trying to figure out what 8 to the 6th is right now with no calculator. I'm not totally crazy. I'm only a little bit crazy. So I'm not going to sit here and torture myself and figure out what 8 to the 6th is. I know what 4 squared is, but I'm just going to leave that alone for now. I'm going to go ahead and do quotient property. Right? So take this, condense it down to 1 natural log, and then divide the arguments. Again, do not grab that calculator. We're going to find a way around this. How can I simplify this without using a calculator? What sneaky thing can I do? Be creative here. What can I do?
Make them the same base.
Bingo, make them the same base. Good job. And the reason I'm making them the same base is because there's a property from Algebra 1 that says if you have division with exponents where the bases are the same, you can subtract those exponents. So I cannot do that right now because my bases are 8 and 4, but I can be sneaky and change the bases to make them the same. So I'm going to change those 8 and 4 bases. I'm going to change 8 to 2 to the third. That is still 8. 2 to the third is still 8. And then the 6 has to come down into the exponent. Do the same thing in the denominator. I'm going to change 4 to 2 squared. 2 squared is still 4. I'm allowed to do that. And then I'll bring down that 2 from the 4 squared. Clean this up. Now you can subtract your 18 and 4. I'm not crazy. Don't go and figure out what 2 to the 14th power is. You're not using a calculator. There's one more thing we're going to do. It's like the proper way to write a log. We don't want this like exponent there that bothers people. So take the exponent and chuck it down in front. Power property. When you read this out loud to yourself, make sure you're not thinking it's 141 N2, okay? Make sure you know that in your head that it's 14 ln of 2. I've had lots of people turn their ln's into 141s before. Just be careful. Fun. We used to do so many of these. It used to be so much fun. It was like a little puzzle. They would give you the beginning and they would give you the end, and you had to figure out how that happened. They took it out of our curriculum, and I miss it so much because they would be so complicated. I miss it. So this is just like a brief little introduction to this. All right, last thing I'm going to show you is a word problem with compounding continuously. So we're the wording of this question is what you saw before. Remember we had that other formula. I'm just going to put it off to the side here. This was the formula we used for compounding monthly, quarterly, weekly, etc. We're not using that one right now. As soon as you see the words compounded continuously, or continuously compounded, Either way, you are going to think about this formula. The PERT formula. The PERT formula. A equals PE to the exponent of RT. So the RT is the exponent for the E. You only use this formula if you see the phrase compounded continuously. That's it. Never ever use it besides that phrase. If you see compounded monthly, you use that other formula in the upper right-hand corner. The variables are exactly the same as what they were before. So P is your principal, R is your rate as a decimal, T is your time, A is your final amount, E is not a variable. I had a question only a few times in the 13 years. Someone said, what goes in for E? What do I substitute in for E? What does E stand for? E is the number, 2.718. You're going to use the E button on your calculator. Do not put 2.718 into your calculator. So go ahead and substitute these numbers in. You've got your P, your R, and your T. Plug them in. So this is the decimal I got. Money, always 2 decimal places. Don't put 3. 2 decimal places for money. Unless it says like round to the nearest dollar. If it says round to the nearest dollar, well then it's 1878. How do we feel? This is all the whole lesson on E.
It's pretty straightforward.
Oh, good. Good. Yeah, I think so too. I think so too. Thank goodness Jitesh showed up today. I'd be so lonely if he wasn't here. The only one that talks to me. Now, 2 things before I let you guys go, and maybe you'll go shovel during your lunch period. Oh, it's starting like here. It's starting to look like sleet. Oh, gross. I'm going to go out and shovel in this yucky weather because I don't want that sleet to get like really heavy snow. 2 things before you leave. Your chapter 7 test is Tuesday. I will be after school on Monday for extra help. That is the joke from the book. It's so bad. And last year, was it last year or the year before? I had a Kurt, and Kurt was so angry. He's like, Miss Ingley, this is like embarrassing. You have to take my name out of this, this joke. So if you know a Kurt, it might be him because I don't know many Kurts. Tomorrow, I have a review game planned. Hopefully our internet is better tomorrow, but I have a review game planned for tomorrow just for fun on a fun Friday. And then Monday would be a review sheet day and like question and answer day. I posted the review sheet already. I'm saying these directions verbally. I'll say them again tomorrow. For the review sheet, it's due by Tuesday. You only need to do whatever you feel you need to do. Meaning, if you only do half the questions, I will give you full credit. If you only do a quarter of the questions, I will give you full credit. If you do every question more and more, I will give you full credit. So for the review sheet that's due on Tuesday, it is up to your discretion how much you decide to do. I'm giving you adult power there, okay, in charge of your own education. Last thing is these were the 2 questions we didn't get to. So I'm going to post the answers right here. And then if you want to take a screenshot and try them later, you can as extra practice. So these are just more challenging solving equations. I believe the homework will also have some for you to try, of course. Okay, so if you want to take a screenshot of those, go ahead, and then you can try them at your leisure when you need to. Or if you need help with them, I can go over them tomorrow before the review game. All right, homework sound classroom. Help your parents shovel, stay safe, and have a good rest of the day. Any way you can put screenshots of today's homework questions to today's post? Oh, because of your internet? Is that why you're saying that? Yeah. Okay. Yep. I can do that. I can do that. Sure. Good suggestion. Thank you.